Hello students, I am Shivangi Anand, your science teacher, and today's topic is latent heat. So what does latent mean? The word latent means hidden. So there are two types of latent heat. One is latent heat of fusion and the other is latent heat of vaporization. So, in latent heat of fusion, a solid substance gets converted into liquid and a liquid gets converted back into solid. When a solid converts into liquid, then the latent heat of fusion is needed. And when a liquid converts back into the solid, then the same amount of heat, latent heat, is given out. Similarly, latent heat of vaporization takes place when a substance converts from liquid state into gaseous state, or you can say vapor state. From the vapor word it has come vaporization. Again, when a substance converts from liquid into gaseous, then latent heat is given to the liquid, and when a substance condenses back, we all know that the process of conversion of gaseous substance into liquid is known as condensation. So when a substance condenses from gaseous state to liquid state, then same amount of latent heat of vaporization is given out. While moving forward, the heat is added to the solid in order to convert it into liquid, and in order to convert liquid back into solid, the latent heat is given out. Again, when the liquid is converted into gaseous phase or vapor phase, the latent heat is given, and when this gaseous state or vapor state converts back into the liquid, the latent heat of vaporization is given out. So, in order to understand deeply what is latent heat, we have just arranged this setup in which we have taken ice at, let it be at minus 50 degrees Celsius, and we are adding heat to it. हम इसको constantly heat दे रहे हैं, and then we will notice what will happen to the temperature when we are adding heat to it. So what will happen? Initially when we are giving heat to it, क्या होगा? What will happen? The ice will start to, we all know that ice is solid, and solid substances are very well packed. They are closely packed. The intermolecular spaces are very, very small, and the intermolecular force of attraction is very, very high. So what will happen when we are giving heat to it? Then the particles, they start to the kinetic energy of the particles increases, which means that they move with the higher speed when we are giving heat to it. So as the kinetic energy increases, so the temperature increases. But this increase in temperature takes place till a point when the temperature goes up to from minus 50 degrees Celsius, the temperature rises to 0 degrees Celsius. At 0 degrees Celsius, which is the melting point of ice, that when we further add heat to it, the temperature will not rise. So where did the heat go? जो अब हमने उसको टेम्परेचर दिया, अब हमने उसको हीट दी, तो टेम्परेचर नहीं इंक्रीज हुआ आइस का, बट क्या हुआ? वो हीट कहाँ यूज होगी? दैट हीट विल बी यूज्ड इन ऑर्डर टू overcome the force of attraction between the particles, so that it converts from solid state into liquid state. See, we all know that the force of attraction in the solid state is higher as compared to the liquid state. तो अब 0 डिग्री सेल्सियस पे क्या होगा, सब्सटेंस क्या करेगा, आइस क्या करेगी, मेल्ट होना स्टार्ट हुई है अभी, तो उस टेम्परेचर पे जो उसको हीट दी है, अब जो हीट यूज होगी वो पार्टिकल्स को एक दूसरे से दूर ले जाने में यूज होगी, ना कि उनकी स्पीड बढ़ाने में। स्पीड मीन्स काइनेटिक एनर्जी। तो दैट इज व्हाई टेम्परेचर हैज नॉट इंक्रीज, बिकॉज दिस हीट, this much of heat is used in, this is known as latent heat of fusion. This heat is used in converting the 1 kilogram of ice in from solid state into liquid state. So thus we arrive at the definition of latent heat of fusion. Latent heat of fusion is the amount of heat required to convert 1 kilogram of any solid into liquid state at its melting point. At its melting point. So अब further क्या होगा, now if we again provided heat to it, then what will happen, now that the entire ice has been converted into liquid state, now after the complete conversion into the liquid state, now when we will add heat, now the temperature will increase. Now the temperature has increased, it will increase. Where will the heat go? It will start to increase the kinetic energy of the particle, so much so that their kinetic energy increases so much so that they start to convert into gaseous form. So now again the same thing will happen. We know that the intermolecular forces between the liquid state are more as compared to that in the gaseous state. Now again, at the boiling point of water, which is at 100 degrees Celsius, the temperature rises to 100 degrees Celsius, and at 100 degrees Celsius it starts to remain constant. So where did it go? Why is the temperature not increases? Where is the heat going? The heat is needed to overcome the force of attraction of water at liquid state in order to convert it into gaseous state. So this heat is known as the latent heat of vaporization. So coming to the definition of it, latent heat of vaporization is the amount of heat needed or required to convert 1 kilogram. Remember student, you have to mention two things. 1 kilogram at the melting point for latent heat of fusion, and 1 kilogram of liquid into its vapor at its boiling point. We all know that boiling point is the temperature at which a substance converts from liquid state into gaseous state. So this heat is used up. Now you know that why is the temperature not rising at the melting point and at the boiling point, because the heat given is not used in increasing the temperature. The heat given is first used up in breaking the bonds of ice to convert it into solid state into liquid state, which is the latent heat of fusion. And over here, at boiling point of water, it is used up in converting the particles of liquid state into gaseous form and overcoming the force of attraction. So now from this you can say, here it is in both these states we have water as well, and here we have ice at 0 degree Celsius, and now now it is started to convert into water at 0 degree Celsius. And here we have water at 100 degree Celsius, and also we have steam, or you can say vapors at 100 degree Celsius. So from this too you can see that ice is cooler as compared to water. Ice is cooler than water. One thing, why? Because ice has latent, because water has latent heat of fusion in it. You can see that ice को water बनने के लिए क्या चाहिए? Latent heat of fusion. और latent heat मतलब उसको heat चाहिए, यानी कि ice में कम heat है as compared to water. Water में एक additional heat कौन सी है? Latent heat of fusion. और वो heat क्यों use हुई है? In order to overcome the force of attraction to convert solid into liquid. Same question. You can be asked that why do we feel more burns when which causes more burns, steam at 100 degree Celsius or water at 100 degree Celsius? From this graph you can see that water is also at 100 degree Celsius and steam is also at 100 degree Celsius. But when we check this scale, heat wala scale, at heat scale which is more? Steam, because it has latent heat of vaporization included in it. So steam is hotter. Steam is hotter than water at 100 degrees Celsius. Similarly, ice is cooler than water at 0 degree Celsius. So this is about latent heat of vaporization and latent heat of fusion. Thank you, students.